At 5:42 in the morning on September 26, 2014, a fire alarm sounded in the basement of a nondescript building in Aurora, Illinois. From the outside, the building looks like an office park. There is no control tower, no runway, no aircraft anywhere in sight. But inside, 400 air traffic controllers were responsible for 91,000 square miles of American sky, and on a typical day, more than 6,000 aircraft. This is the story of how one person, working alone, took down one of the busiest air traffic control facilities in the world and exposed a vulnerability the FAA had spent decades pretending didn't exist. The Chicago Air Route Traffic Control Center, known to controllers simply as Chicago Center or by its three-letter identifier, ZAU, sits roughly 40 miles west of downtown Chicago. It is what aviation engineers call an en route center, one of 22 facilities in the United States that manage aircraft once they leave the airspace immediately around an airport. If you've ever flown across the country, your aircraft was handed off from one of these centers to the next, like a baton in a relay race. Chicago Center is one of the most critical links in that chain. It sits at the geographic and operational heart of the National Airspace System. Almost every transcontinental flight in America passes through its airspace. Just before dawn on September 26th, a contract technician named Brian Howard entered the basement of the Aurora facility. He had worked there for 8 years. He had the access codes, the security clearance, and intimate knowledge of which cables did what. He lifted the floor panels. He cut specific bundles of cables. He poured gasoline. He lit it on fire. 4 floors above him, controllers were managing the early morning push of cargo flights and the first wave of commuter traffic. They had no idea anything was wrong until the radio frequencies started going dead. One controller's last transmission before evacuation has been preserved in public records. He told an aircraft on emergency frequency 121.5 that the building was being evacuated and to contact the nearest FAA approach facility for help. Then the radios went silent. The radar screens froze. And then, within minutes, they went black entirely. To understand why this single fire was so catastrophic, you have to understand what was actually burning. The fire wasn't in the control room. It wasn't even in the radar room. It was in a telecommunications closet that housed something called the FAA Telecommunications Infrastructure, FTI for short. FTI is the nervous system of the Air Traffic Control Center. Every radar feed, every radio frequency, every digital flight plan, every connection to neighboring centers, all of it passes through this one piece of infrastructure. One of the controllers later described it as the switchboard through which all systems communicate. And here is where engineering design meets uncomfortable reality. The Chicago Center had a backup system. Aviation engineers had built in redundancy, the way they're supposed to. But the primary and the backup were housed in the same room. The cables ran through the same junction. When the fire took out the primary, it took out the backup at exactly the same moment. This is a phenomenon engineers call common cause failure. It happens when your backup system depends on the same physical resource, the same room, the same power feed, the same cable run as your primary. On paper, you have redundancy. In reality, you have a single point of failure with 2 labels on it. Within 30 minutes of the fire alarm, every commercial flight at O'Hare and Midway was grounded. By that afternoon, more than 2,000 flights had been canceled. The ripple effects spread across the entire continent. Jets bound for Atlanta were rerouted at altitudes hundreds of miles lower than normal, because the airspace they would normally have used was now jammed with traffic that had nowhere else to go. If you find these stories of hidden infrastructure as fascinating as I do, the systems most people never see until they break, consider subscribing to Engineering Your World. New episodes every week, and a new episode in this series on air traffic control failures is on the way. What happened next is one of the most underappreciated stories in the history of American aviation. The 4 ARTCCs that border Chicago Center Cleveland, Indianapolis, Kansas City, and Minneapolis had a problem. Each of them had been designed to handle their own airspace. None of them had been designed to handle a chunk of Chicago's. Their radar systems could see into Chicago's airspace, but not very deep. Their radio transmitters could reach into it, but only at certain altitudes. Their procedures didn't cover any of the unique geography of the missing region. So they did something extraordinary. They got out paper maps, and they started drawing lines. Kansas City controllers experimented with their own equipment to find out how far north they could actually see, and discovered they could reach all the way to Joliet, Illinois, just outside the Chicago metro area. They activated radio frequencies they hadn't used in years. Indianapolis Center reopened sectors of airspace they had given up decades earlier because the radar coverage was still there. It had just been retired. They installed a dedicated landline phone, a literal wired telephone, to pass flight plans back and forth. Controllers from Chicago Center were dispersed to 19 other facilities. Some traveled to smaller regional airports like South Bend and Milwaukee, where they were recertified on equipment they hadn't touched in years. Meanwhile, back at Aurora, FAA technicians made a decision. The damaged equipment couldn't realistically be repaired in a useful time frame. So they decided to do something almost unheard of. They would rip out the entire damaged telecommunications system and rebuild it from scratch, on a different floor of the building. They brought in the best technicians from across the country. They worked around the clock. 17 days after the fire, on October 13th, 2014, Chicago Center came back online. The Department of Transportation's Inspector General investigated the FAA's response and was, in diplomatic language, not impressed. The official contingency plan the FAA had on file didn't actually contain procedures for transferring an entire center's airspace to its neighbors. The agency had to fall back on an outdated 2008 plan and a tremendous amount of improvisation. The Chicago Center fire forced 3 uncomfortable lessons into the open. First, redundancy is not the same as resilience. If your primary and backup systems share any physical resource, the same room, the same power feed, the same person who has access to both, you don't have a backup. You have 2 copies of the same single point of failure. Second, a contingency plan that has never been exercised is not really a plan. It's a document. The neighboring centers ultimately succeeded not because they had a written procedure, but because their controllers were able to improvise with paper maps and pencils. And third, and this is the one that's harder to engineer around, the most trusted insiders can become the largest threats. Brian Howard wasn't a hacker. He wasn't a terrorist. He was a contractor with a badge, 8 years of access, and a personal crisis. The FAA has since added insider threat monitoring and access restrictions, but the fundamental tension between giving technicians the access they need to maintain critical systems and protecting those systems from the technicians themselves has no clean solution. The next time you fly across the United States, your aircraft will likely pass through Chicago Center's airspace. Controllers in a quiet, unmarked building in Aurora will hand you off to their counterparts in Cleveland or Kansas City or Indianapolis, exactly as they've done every day since 1963. The system works. Most days, it works invisibly. But it works because of choices that engineers and controllers are still making every day, about where to put the cables, where to draw the lines, and what to do when one of the cables catches fire. Coming soon on Engineering Your World, we'll look at what happens when the radios themselves fail, and at one of the worst mid-air collisions in modern aviation history, caused not by a fire or a power failure, but by a single moment of misunderstanding between a controller and a pilot.